Hi. During the course of this conference, you've learned lots of cool stuff, and I know it can be overwhelming. So before I even begin with what we're going to learn today, here's what I want you to remember. I'm Michelle Brenner, and everything I'm going to cover will be on my website. You can also go straight to the example project repo. Don't feel like you have to frantically take notes or remember everything. It's all available for you to copy and paste into your own project. If there's one thing I want to make sure you remember from today, it is this. Do less, accomplish more. So let's make some cool stuff, but not work too hard. Today, you're going to learn about how to use data to help you get a raise. I'm going to discuss my method of collecting and formatting the data. I'm also going to show you how to build and deploy your own tool to track and report the data using AWS and Python. Personally, I'm a project-based learner. So my goal here is to demonstrate a new technology and a practical business skill. That way, you can accomplish two things at once. You learn a new technology and have a method for improving your career. Because I want you to do less and accomplish more. Here are the different tools I use to make the app. I'll be going into a lot more detail later, but just so you know what we'll be covering. If none of these words mean anything to you, great, I'll explain it. If you're an expert, please stay anyway, but also give me your email address because I still have lots of questions. Now that you know the tech, this is going to be our agenda. Why did I choose these tools? A definition of all the terms so we're on the same page. What is this app, and how is it going to help me with raises? The data we're going to collect, actually creating the app, and finally, the alternatives to the tools I mentioned and future plans for the app. I'm going to start with why did I choose these tools? To explain why these AWS services and serverless apps in general appeal to me, I want to give you a bit of my background. 8 years ago, I got an extremely practical degree in 3D animation. Luckily for me, I had some experience coding. So when a job came up to work in a tech department at a VFX company, I jumped at it. Working in entertainment technology is very different than other large technology companies. Technology is not their business. Art is. It's just a means to an end. Anything that will get the artists producing faster or higher quality images will be used. This work cycle is also not in sprints, quarters, or years, but instead is counted in projects and film shots. My first job was focused on reducing the company's biggest expenditure, artist time. If you were working on a tool and it was not done fast enough to actually help on the project you were contracted to work on, it was useless. This taught me to be practical and put business needs first, not technology. If that wasn't my first job, I would definitely suffer more of the consequences of what I like to call the engineer mindset. Having an engineer mindset means never being able to turn off the part of your brain that says, I can tackle any problem, even if I don't have any expertise or background on it. How many of you have been waiting at a store or an event and thought to yourself about how an app could make this go better? I don't want to tell you how many grocery store apps I've envisioned in line. I've never worked on logistics, but because I can't turn it off, I want to fix the issue. The problem-solving mindset is generally a positive trait, but can lead to some unintended consequences. Let's talk about a common scenario engineers face. You are given a work assignment. Your customer wants a big new feature. You now have two choices. You could either start coding right away or spend a bunch of time researching. I know what I want to do. Getting code on the page seems like it will be faster and a lot more fun. But let's think about this. By not taking advantage of available open source tools, you're saying that you have a better solution than everyone who has ever had the same problem. Sure, you might be smarter than one person online, or even two. How about 100 people? 100,000? You can never beat that as an individual. Of course, not every problem has been solved, and you might have to adjust what you find to fit your specific needs. But if you can describe your need as a general technical issue, 100 others probably have already. So why not let the tech community help you so you can do less and accomplish more? You're probably wondering, what does this have to do with serverless apps? Or if you're me a few months ago, what is a serverless app? I'll get to that. I like to think of serverless apps as someone doing work I'm not interested in, so I can focus on getting great features out for my clients. They're also a great example of letting 100,000 people solve your problem. Before I started working with serverless apps, most of my projects met a dead end at the same place. I was great at designing APIs and functions, but had no interest in DevOps. So when it came to actually learning how to deploy my app, I would see about 20 different concepts I didn't understand and give up. It wasn't that I was incapable, it's just not what excites me. So I did not make the time. Before I get into the technical details, I'm going to define some terms. I know that you're here because you're interested in Python, but one of the joys of Python is that the possibilities are endless. The projects I make and the projects you make could be totally different. So let's start with the one you've been waiting for. Here's a definition from AWS on what a serverless app is. Serverless computing allows you to build and run applications and services without thinking about servers. Serverless applications don't require you to provision, scale, and manage any servers. You can build them for nearly any type of application or back-end service, and everything required to run and scale your application with high availability is handled for you. You know what that sounds like? Doing less and accomplishing more. Now, let's talk about the app itself. What are the basic building blocks of an application? I'm sure you could debate me on this, and now that you know, you can find me on Twitter, definitely will. But for the purposes of this talk, I've broken it up into 5 parts. First is the data storage, or some way of having persistent information. It could be anything from a MySQL database to a text file, some way of taking data and holding on to it. Next is the algorithm, doing something with the data. Do calculations, organize it differently. It doesn't matter as long as you're changing it in some way. A quick aside here, if you're not changing anything, you probably don't need to make this app. One of my art teachers used to say, with animation, anything you can imagine, you can make. But if you could just film it, it's a lot cheaper. If you don't need to change anything, don't build an app. After that is the interface. This is some way of running the algorithm and accessing the data. It could be an API, a script, or even a graphical interface. Next is the home, somewhere to store your app that is outside of your computer. And finally, the deployment, how to get your app to its home. Now that we know the different parts of the app, before we get to the specific tech, let's talk about the app we're going to make. The app is called ROI Tracker. We're going to make an app that tracks your personal return on investment so that at performance review time, you have the numbers to make your case. I like to use the business term ROI because it puts me in the mindset of, am I making more money for the company than they are spending on me? Am I making them a lot more? Do they know that? And if not, I'd better tell them so they give me more money. How we do that is with a formula called success statements. The origin of success statements is from a communications failure. A manager was given a large team. After a year, she was called into the office of the vice president and asked what had she done with the last year. While she knew she had grown her team and implemented many improvements, she did not have the numbers to back it up. To the vice president, it looked like she had hardly done anything all year, when she felt like she had gone above and beyond. This is when she developed success statements. Success statements are a way of translating your accomplishments into the language everyone in business can understand: money. The content of success statements should be these 3 things. It should be 140 characters or less, just like classic Twitter. You should be able to scan through a list of them like a resume. They should be written at a high level and easy to comprehend for someone who might not understand what you do. They should be quantified in money or time. Money is the easiest, but since salary can be one of the biggest corporate costs, time can be translated into cost savings. Here's the exact format of the sentence. By having a consistent format, it's easy to read and keeps you on message. I improved this thing using this method by this measurable amount. Here's an example of one. I reduced storage costs by archiving data, saving $5 monthly. Reduce storage costs is improve this thing. By archiving data is this method, and measurable amount is $5 monthly. Here's a second example using time. I reduced the manual testing by creating automated tests, saving 60 minutes weekly. Reduce manual tests is improve this thing. By creating automated tests is this method, and their measurable amount is 60 minutes weekly. Now you might be thinking, I have learned this great communication method. Thanks, Michelle. But why do I need an app to track them? There are only 2 examples, but at the end of the year, I would have 100. I'd have to manually comb through them, figure out which ones to include by date, and calculate the savings. It was a pain. That's why I made ROI Tracker. Earlier, I went over the parts of an application, which you'll see again on the left. On the right, you'll see the tools I use for each. DynamoDB is the data storage. It's a non-relational database. It's more like a dumping ground for data instead of a well-organized SQL database. However, it's easy to set up and use, so great for small apps. Lambda holds the algorithm. This is the meat of the serverless app. A Lambda is simply a function. That's it. If you've written a script or a tool before, you can transfer that into a Lambda. API Gateway is the interface. It handles the routing, views, and schema validation of a traditional web framework. S3 is the home. S3 is a flexible storage area and connects easily with other parts. There are many ways to deploy a serverless app. For this one, I found SAM to be the right fit. SAM uses a YAML template to tell AWS, these are the services I want to use, please set them up. There are simpler ways to do this, such as Chalice, a Python library, or more robust, such as CloudFormation. But for this app, I took the middle ground. One final step before actually making the app. I need to know what data I want to report it. What are my goals here? I landed on 2 things. In a given time period, such as the last year, I want to know the total time and money saved. I want to know not just my immediate impact, but over the entire year. If I saved $100 on a monthly process, that's $1,200 after a year. If I saved 10 minutes a day, that's 43 hours a year. If the employee I saved was making $20 an hour, I saved $860 that year. These small changes add up. So what information do I need to collect to get these totals? For the total time, I collected these 3 things for each innovation. The duration in seconds, or how much time I saved, when I started saving the time, and how often it recurred. Was it daily, weekly, yearly, or just once? For total costs, I collected similar information, except cost in cents instead of duration in seconds. Finally, to make sure I give my report entirely in money, if necessary, I needed to convert time to money. For this, I used the number of employees affected by the innovation and their salary. Of course, not everyone can get employee salaries, so it's optional. Now it's time to create the app. While I explain the different AWS services I use for the app, I'm going to keep referring back to the SAM template. So I'm going to go over that first. What is SAM? Quoting AWS, you can use SAM to define serverless applications in simple and clean syntax. SAM is a helper that creates the CloudFormation template. CloudFormation is a YAML template that you can use to tell AWS, I want to use all these services and have them connect in this way. If you want to do something more complex than what SAM provides, such as setting up a virtual private cloud, you can use CloudFormation commands directly in your SAM template, and it will pass it along to the CloudFormation template. So just to be perfectly clear, SAM uses a YAML file that translates into a more complex CloudFormation file that AWS uses to define the app. This is the top of the YAML file. The top 2 lines are boilerplate and just a simple description of your app. The next section is parameters. You will use these when creating names for the different parts of the app. The stage name parameter is so that you can have ROI trackers in different environments like QA and production and easily see which ones you're working on. By starting all your components with the service name parameter, they're easy to find when you have multiple apps. And the next step is defining the data storage. Let's go to the resources section of the SAM template. Resources are components of the app, like the data store and the interface. This is the data store resource. DynamoDB is a non-relational database fully managed by Amazon. While I would have preferred that relational database like MySQL, that takes more work to spin up and manage. I opted for ease of use. You can see where I have started to use the variable names we set up at top of the SAM template. I also set the ID as the key and set the throughput low since only I'm using it. When actually accessing the database, I use the Python SDK. After I initialized the client, I created a table. Then I was able to use the table to get all the CRUD components. I created an item using put because there's no dedicated create in this SDK. It will create the item if it doesn't already exist. Then I received items in 2 different ways. As a single item, or by running a scan to get all the items. Again, this should be a small table, so getting all the items shouldn't be that time-consuming. For the update, I use that same put I used before, and finally, delete to get rid of all my mistakes. Now, let's talk about the interface. I use API Gateway to define all the views. An API Gateway endpoint can activate other AWS services. In this case, I connected it to a Lambda, which I'll go over more in the algorithm section. I decided that I needed 5 endpoints for this project. I always start with the CRUD, so the post and get on the plural successes, and then a put, get, and delete on the success with an ID. I added one more called report to present a summary of the data. In order to define the endpoints and add features such as schema validation, I use Swagger. What is Swagger? Quoting swagger.io, Swagger allows you to describe the structure of your APIs so that machines can read them. Swagger is an open source tool that AWS supports. AWS can read a Swagger file and define the API gateway accordingly. I added the Swagger definition directly in the template, but you can also use a separate file. Here's how that looks. Here's a quick look of a single endpoint, but I'm sure it's hard to read. Let's zoom in on some of the main features. I'll be skipping around, but you can find all of this in the repo with many examples. First, defining the resource of an API gateway. Again, you can see the variables in the name. Next, we'll jump to the start of the Swagger definition so you can see where I added it into the definition body. Right under that, we set up a validator called basic that says to validate both the body and the parameters. Since DynamoDB is that NoSQL database, it doesn't inherently allow for limiting the data that can go in it, but I wanted to keep organized, which is why I added the validation here. After that is the beginning of the paths. Here's the initial post. Here's where it says to make sure a body is provided and to validate against the schema success. Right over here, the definition of success. The success schema is all the data we want it collected, such as the duration and the start date. Finally, this section tells AWS to connect it to the Lambda so the endpoint actually does something. Now, let's talk about the algorithm. Lambdas are functions that AWS runs for you. That's it. The definition from Amazon is AWS Lambda lets you run code without provisioning or managing servers. You pay only for the compute time you use. There's no charge when your code is not running. Pretty neat. I won't go over the Lambdas using the success endpoints because you saw most of that code when I went over the DynamoDB SDK examples. Instead, I'll go over the report Lambda. Here's what it looks like in the SAM template. I'm going to highlight a few sections. The handler determines which file to find that function in this case, report Lambda. I want to make sure it knows how to find that database table, so I pass it along as an environment variable. And here is where I link the Lambda back to the API resource that has that Swagger definition we already went over. Finally, the policies give the Lambda permission to actually access the database we made. I made a bunch of functions for the Lambda to call. Remember the totals I wanted calculated? These functions do it all. If I name them right, they should be self-explanatory, but you can see the actual code as well as tests with a bunch of examples in the repo. The only remaining step is to actually push this to AWS. This requires an S3 bucket to store the actual files. Then you can use SAM to package and deploy. I created 2 shell scripts to help with this, and they're included in the repo. Whenever you create a new file or add a new package to your repo, you need to run update build. It puts the files in the right place for SAM to find. When you're ready to actually deploy your stack, you run test stack. You can find more information about how these shell scripts work and the commands they contain in the repo README. Once that is successfully pushed, you can double check everything you made and test through the AWS web interface. You can actually sidestep the entire SAM process that I went over and create everything in the web interface. But that's more burdensome when doing large projects, and I also found lots of tutorials on how to use the GUI, but much less that help with the SAM syntax. So I wanted to make sure if you want to make a production-ready tool, you don't experience the same frustrations I did on syntax. Here's how your API will look. As soon as I had my basic API, I was able to post all the successes that are included in the repo tests. Then, when I run the report endpoint, I get a summary ready to bring to my performance review how I saved $130 in the past couple months. There are a bunch of features I haven't included in here, but you'll want to make sure you do for a completed web app, such as securing your endpoints. It would also be nice if I could auto-generate some cool graphs on some of these numbers. There are also other companies offering services similar to Amazon, such as Microsoft and Google. I've heard good things, but I haven't tried it myself. The concepts are similar, so try it out. It's all free on the development tier. And if you could report back your findings, that would be swell. If you're thinking, Michelle, you just keep giving us more homework, and it seems like it will benefit you. You're right. I want this presentation to be your jumping off point and learn cool things that I can use. Because, as you have to know by now, all I want to do is do less and accomplish more. Now, I bet you're wondering, what happened to that manager we talked about earlier? How did using success statements help her career? She became a director and is currently in charge of multiple departments. After she taught her team members about success statements, they were also able to achieve great things. These include, every year, 25% of her employees are promoted. At her company, 18% of those receiving company awards and 25% of those celebrating 15 years with the company are from her department. I hope this inspires you to build your app, gather your data, and impress your boss. This will show all of your hard work, and your bosses will have no other option but to give you a raise. You're welcome. Feel free to send me a percentage of your newly acquired wealth to help subsidize my crippling Starbucks addiction. Anyone who wants to continue this conversation, feel free to reach out to me on LinkedIn, Twitter, or one of the many public Slacks that I'm on. If there are enough people, I might arrange a group discussion or even open up the project to contribution. Like I said, I have plenty more to do, and I know there are probably a few of you who might not have questions now, but will think of some later. I'd love to keep the conversation going. Additionally, I appreciate any feedback on this presentation today as long as it's positive. Any questions?
We've got about 15 minutes for questions, so I can come around with a roaming mic. If anybody has any questions, you can go ahead and raise your hand.
Does using success statements like these as part of your review with your boss lead you to having goals that are set against some of these saving time or saving money, and does that make it hard for future performance reviews?
I actually don't think it's really really affected the goals I want to have, because your goals are more set by what the business goals are by the company, like what features they want to have, how you want to grow yourself. I think it just shows extra things you've accomplished throughout the year that say you made that new feature, look at what that feature accomplished for the company.
For someone that hasn't tried any app development or hosting on any of these services, is there a good tutorial that you would suggest or recommend for kind of getting started and all these different pieces that you mentioned and components, kind of the most basic level, easiest to get going?
Yeah, AWS itself actually has some really great tutorials. So I'd start with the meat of it, which is the Lambda, right? So you can say, I want a Lambda to just add up a series of numbers or something like that. So that'll be your example. And if you go to AWS, you can start right in the web interface and say, I want to make my first Lambda in Python, and I want to write a test for it. And it'll go through each step of the way. Companies like AWS and Google and Azure, they really want people to use their products. So they do everything they can to document it and make sure that the people who are doing development don't have to pay for anything. So I believe it's at like 1 million calls when you start having to pay for things, which is nice.
Hi. So are you, besides being the developer of the app, the primary or maybe only user of the app, or do you give the app to your manager so they can see what you did throughout the year?
So I just made it just now, recently in the last couple of months, because I was like, I want to learn serverless apps. So I was doing a little bit at work, and then I was like, what is an app that I've wanted to deploy for a long time? And I was like, oh, I really want to put this app together. So I haven't showed it to my boss yet, but hopefully he enjoys the video of this presentation and sees how much hard work I've been doing.
Oh.
So what was the hardest part of this to learn, or the most frustrating part? Like worst documentation or whatever reason?
Yeah, it was like the weird errors that I couldn't figure out how to explain. So there's like a strange error sometimes where the API gateway doesn't connect right to the Lambda, and then if you just like refresh the page, it does. It's things like that where it's like you don't learn that until you run into it, and it's hard to Google that. So things like that, and some of the syntax in the SAM, like the really basic things, like making your first Lambda is super straightforward. There's lots of examples. But when you want to do something a little more complex, like adding in the Swagger, or on my work project, not in here, I did use a MySQL database, and that was a little more complicated. But there is plenty of documentation, and you can see a lot of examples, especially of the CloudFormation templates, where you can try something out, see if it makes it, and then just keep going back and forth and just keep, I called it test stack, not deploy stack, because I kept testing it over and over and over again. I think I even have like a delete line in there every time I retried it. So I believe that answers your question.
Could you possibly flip it and use it to track your boss, or like, you know what I'm saying? Just
see what they're up to?
See, well, not track them in like a stalker kind of way, but just like get data. Yeah. I mean, yeah, something like that.
I mean, you can do anything with
right?
it.
Okay.
Like I said, it's a non-relational database. You could put anything you want in there. If you want to just use it and like every day, you're like, they've been in that lunch meeting for 3 hours. Just like put it in there, and then over the course of the year, be like, how long have they been in lunch meetings? And it's like 1,000 hours. You're like, what are they up to? Are they starting their own company during lunch? Like, what is happening? It's a little more nefarious. I don't know if you can tell that to anyone that you're doing that.
Have you ever thought of tying it to a ticketing system like Jira to track your data and be able to present it back to your manager?
Yeah, that would be great. I think too, to show results, I think that would be awesome. There was actually a presentation here yesterday about hacking Jira, and now that I know more about that, I think that's an excellent suggestion for a new feature. The first job I was talking about with that manager, we actually didn't have any sort of ticketing system. It was kind of just like, just do stuff. So that was part of the problem, right? We weren't tracking anything in any way. So at the end of the year, you're like, what did I do? I don't know, stuff.
Are there any resources you would suggest for just learning more about non-relational databases in general?
I'm trying to think if there's anything on. I would definitely look at DynamoDB, since there's a lot of information on that, and also on Mongo. Most of the time, it's not that useful. Like, that's why I had to say like a bunch of caveats. Like, I use it because it was like really easy for this. But anytime you're doing a super large production project, I found that MongoDB and other non-relational databases can just get frustrating if you're planning to have a bunch of interrelated tables. But there are definitely use cases for it. And the nice thing is, it is just a dumping ground. So if you just want to play around with things and you don't actually, like maybe I haven't decided what data I want, I just want to like put some data in a table, I think it's a great use case. And you can go on AWS to see the DynamoDB or look at MongoDB, because those are kind of the big ones that people are using right now.
This is really just a quick one, but I know from learning about AWS, you can really nickel and dime yourself to death, but how much did you spend on running this with AWS?
I'm going to repeat the question since she didn't have the microphone. So she asked how much I spent on AWS. I spent $0. I clicked the little button in the settings that's like, please alert me if I spend any money. And I also, I looked at, between this and doing some projects at work, I did like all the calculations of like, what is actually going to cost me money here? And most of it is actual usage. And since it's just me using it and not like an app that I'm selling to people, it doesn't cost me anything. And that's a great way, I think. This is both, for me, it was like a useful tool, but also I just want to learn more about how to put things together. So I didn't, plan this in terms of, I'm going to make this app and sell it to 1 million people and everyone's going to start using it. That's kind of a different planning session.
Hi.
Hi.
Okay, cool. So I've only used DynamoDB once, and I found I was using it for really simple things. And the querying syntax was actually a little verbose. There's a lot of data type specifications and stuff. And a friend recommended, well, why don't you just stick a bunch of JSONs in S3 and just grab them by like file name, essentially using that as the index. Have you ever tried something like that or have experience?
I haven't tried that, but I love having examples thrown at me so I can try different things. That's definitely a way to do it. I mean, as you saw, my workaround was like, okay, what are other people doing to define the data? Because I realized the only thing I can define is the ID. And that's where I use it. Like, okay, I stopped it at the API level instead of stopping it at the table level. But there's definitely a million alternative solutions. So thank you for your suggestion.
All right, anybody else?
Okay, I'm going to hang out a little while if you think of something or just want to talk one-on-one.